Okay, today's date is July 9th, 2009, and I'm here in the lab attempting to tune the new secondary circuit for the brand new Tesla coil. My setup today consists of the brand new spun aluminum toroid situated on top of my new 4-inch secondary coil. You can see that the whole setup is mounted here in a base instead of being on top of part of the Tesla coil. And that's for the purposes of tuning today because we don't want other parts of the coil interfering with my measurements. You can also see the oscilloscope probe mounted here in a stand, and attached to the top of the probe is a wire that I'm just using as an antenna. The first wire that you can see running from the base of the secondary is actually running over here to the signal generator, and of course the base of the oscilloscope probe is running to the oscilloscope. So here on the signal generator, I'm using the 20 volt output, and for the range, I'm using the 1 megahertz range. That way I can cover a large frequency range. I'm also using just the standard sine function. I've got a knob here that'll allow me to adjust the frequencies. So, and then over here on the oscilloscope, we're using a digital scope that is going to be using 2 functions. One is just the standard sine wave function, and then also I'll be using what's called one of the frequency map functions, which gives me a spectral analysis of all the resonant frequencies of this coil. So looking at this, you can actually see the tuning in progress. You can see as I turn up the frequency, I hit a peak, and once I pass that resonant frequency, it drops off again. That's actually hitting the resonant frequency of this coil with this setup. And what we want to do is we want to find, and we want to get right to that peak and then keep it there. So it looks like I just passed it. There we go. It looks like I'm hitting around 336, 337 kilohertz, right around that range. Now if I switch over to the frequency, and let's change our divisions down to 125 kilohertz per division, we can again see this big spike right here, which is the resonant frequency of both the secondary coil and the toroid combined. Now, one important thing to keep in mind when you're tuning these is if I change back to our standard sine wave function, if I bring my hand in, we can see how the oscilloscope jumps, how the actual resonant frequency is affected by the presence of outside capacitance. So if I were to stand up again and walk over towards the scope, I can actually, walk over towards the coil, I can actually completely alter the resonant frequency of this coil by adding external capacitance to it. So one thing we might want to do in the future is simulate a streamer that's going to be coming off the top of this coil so that we can compensate for the standard running environment for the secondary circuit. So as far as calculations go, the Java calculator used initially gave me a result of around 349.97 kilohertz. My own personal calculations yielded around 345 kilohertz. And the experimental values that we're getting today are around 336 kilohertz, which compared to our Java calculator yields around 3.5% error, which isn't bad but not great. So as far as everything else goes, it looks like I finally got everything good. Hopefully here in the near future we'll be able to get the primary circuit on the coil tuned to this frequency so that we can get the new coil operating at its optimal efficiency. So thank you very much.